Saturn may be the most beautiful planet we have ever seen, a pale golden world, suspended in darkness, surrounded by rings so precise that they almost look artificial. From Earth, it appears calm, silent, untouched, but that image is a lie created by distance. Move closer, and the peaceful planet begins to disappear. The rings become a storm of orbiting debris. The golden clouds become violent currents, moving faster than the most powerful hurricanes on Earth. And beneath them, there is no surface waiting for you. Only pressure, darkness, and an atmosphere that becomes increasingly hostile the farther you fall. Saturn does not need monsters, volcanoes, or oceans of fire to be terrifying. Its beauty is enough to draw you in. And its gravity ensures that once you begin falling, there may be no meaningful way back. Like and subscribe to The Cosmic Perspective, because today we are traveling beyond Saturn's rings, beneath its clouds, and into one of the most beautiful traps in the solar system. Imagine approaching Saturn in a spacecraft. At first, the planet fills only a small part of your window. Then it grows and grows until the curve of the planet becomes impossible to see. Saturn is roughly 9 times wider than Earth. You could place hundreds of Earth-sized worlds inside its enormous volume. Yet despite its size, Saturn is not a solid world. It is made mainly from hydrogen and helium, the same basic elements that dominate the Sun. There is no continent beneath the clouds, no ocean, no mountain, no hidden surface where your spacecraft could land. You would simply enter the atmosphere and continue falling. At first, you would pass through pale clouds of ammonia ice. The sunlight above you would fade as the atmosphere became thicker. Bands of yellow, gold, and brown would stretch across the sky, driven by immense jet streams circulating around the planet. Your spacecraft might still appear to be flying, but eventually, the distinction between flying and sinking would disappear. The surrounding hydrogen would become denser, the pressure would rise. Gas would begin behaving more like a fluid, and still there would be no ground beneath you. Saturn is not an empty ball of gas. Deep inside, hydrogen is compressed into states of matter that do not exist naturally on Earth's surface. Farther down, the pressure becomes powerful enough to force hydrogen into a liquid. Deeper still, it may become metallic, capable of conducting electricity and helping generate Saturn's magnetic field. You would not reach the center. Long before then, the pressure and temperature would crush, melt, and eventually vaporize your spacecraft. Saturn does not have a surface that kills you. It has an endless descent that gradually removes every condition necessary for your survival. Saturn's soft colors make its atmosphere look gentle. It is anything but gentle. Near the equator, winds can reach approximately 1,800 kilometers per hour. That is several times faster than the winds inside the strongest hurricanes recorded on Earth. These winds do not move through a landscape of trees, buildings, or mountains. There is almost nothing solid to slow them down. They race around the planet in enormous atmospheric bands, some moving east while neighboring bands move west. The result is a world divided into immense rivers of air. From a distance, these currents appear as thin stripes. Up close, each stripe would be an atmospheric region large enough to swallow countries. And Saturn produces storms on a scale Earth cannot imitate. Occasionally, an enormous disturbance erupts in the atmosphere. One of the most famous was observed in 2010. It began as a bright storm in Saturn's northern hemisphere. Then it expanded. It generated a tail of turbulent cloud that stretched around the planet until the storm effectively caught up with itself. A single weather system had wrapped around an entire world. On Earth, storms feed on energy from warm oceans and sunlight. Saturn receives far less sunlight than Earth, yet it still produces immense atmospheric violence. Part of that energy comes from within. Saturn radiates more energy into space than it receives from the Sun. The planet is slowly releasing heat left over from its formation, while helium may also sink through its interior and release additional energy. Saturn is not merely being warmed from above, it is still glowing faintly from within. Its storms are powered by a planet that has never completely cooled down. At Saturn's North Pole, the atmosphere forms something that looks almost impossible, a hexagon. Not a roughly six-sided cloud, not a temporary pattern captured at the perfect angle. A vast, organized jet stream with 6 distinct sides. The structure spans approximately 30,000 kilometers. Earth could fit inside it. At its center sits a huge rotating vortex. Around that vortex, clouds circle the pole while the hexagonal jet maintains its shape. Nothing similar has been observed on any other planet in the solar system. But the hexagon is not evidence of alien engineering, and it is not a symbol carved into the atmosphere. It is physics. Under certain conditions, rotating fluids can form stable polygonal patterns. Differences in wind speed may cause a jet stream to develop a wave. If the wave travels around the pole at the right speed, it can create a shape that appears almost stationary. The explanation makes the hexagon less supernatural. It does not make it less disturbing. This is weather behaving like architecture. An atmospheric system larger than Earth has organized itself into a geometric structure and maintained that structure for decades of observation. Human buildings eventually collapse. Saturn built a 6-sided storm out of wind. Saturn's rings are the feature that makes the planet appear peaceful. From Earth, they look smooth and continuous, but the rings are not solid. They are made from countless fragments of ice, rock, and dust. Some particles are smaller than grains of sand. Others are comparable in size to houses. A few may be far larger. Each fragment follows its own orbit around Saturn. Particles closer to the planet travel faster than those farther away. From a distance, trillions of individual paths blend together into bright, perfect bands. But if you entered the rings, that perfection would disappear. You would find a vast orbital environment filled with moving material. Some regions are relatively sparse, others are densely packed. Tiny moons travel through the system, disturbing nearby particles and creating waves, gaps, and sharp edges. The rings stretch hundreds of thousands of kilometers across, yet the main rings are astonishingly thin, often only around 10 meters from top to bottom. Imagine a structure wider than many planets, yet proportionally thinner than a sheet of paper. Saturn's rings are not a solid disk. They are an enormous, fragile illusion. Their origin remains uncertain. They may contain material from moons, comets, or other objects that were broken apart by collisions or by Saturn's gravity. One theory suggests that a former moon moved too close to Saturn and was torn apart. Another possibility is that several destructive events contributed material over time. Scientists are still debating how old the rings are and exactly how they formed, but we know they are not permanent. Material from the rings is gradually falling into Saturn's atmosphere. Microscopic particles and charged material are being pulled along magnetic field lines in a process sometimes called ring rain. Saturn is slowly consuming the very structure that made it famous. The rings are beautiful because we are seeing them during a temporary chapter in the planet's life. Saturn is surrounded by hundreds of confirmed moons and smaller satellites. Some are battered lumps of ice, others are complex worlds. The largest is Titan. At first, Titan sounds almost welcoming. It has a thick atmosphere. It has clouds. Rain falls from its sky. Rivers carve channels through the landscape. Lakes and seas collect on its surface. It even has dunes stretching across vast regions. From a distance, Titan resembles a frozen version of Earth, but almost every familiar feature is made from the wrong material. Titan's lakes are not filled with water. They contain liquid methane and ethane. Its rain is hydrocarbon rain. Its landscape is so cold that water ice behaves like rock. The average surface temperature is around minus 179 degrees Celsius. A human could not breathe the nitrogen-rich atmosphere, and without protection, the cold would be fatal. Yet Titan is not a dead copy of Earth. It is a world with its own active climate. Methane evaporates from its lakes and seas. It enters the atmosphere, clouds form, rain falls, rivers flow, the liquid returns to the lakes. Titan has a methane cycle that resembles Earth's water cycle. That similarity is what makes it unsettling. Titan demonstrates that a world can possess weather, rivers, and seas without being remotely suitable for human life. It reminds us that familiar landscapes do not guarantee familiar conditions. You could stand beneath Titan's orange sky, beside the shore of an alien sea, and recognize almost everything around you, and none of it would belong to Earth. Farther inside Saturn's system is a much smaller moon, Enceladus. Its bright surface reflects so much sunlight that it appears almost perfectly white. For years, it seemed like little more than a frozen object. Then the Cassini spacecraft discovered something extraordinary. Near Enceladus's south pole are long fractures known as tiger stripes. From these fractures, jets of water vapor, ice particles, and other material erupt into space. Some of this material contributes to Saturn's faint E-ring. But the most important discovery was not the plume itself, it was where the plume came from. Beneath the ice, Enceladus contains a global ocean of liquid, salty water. Saturn's gravity flexes the moon as it travels through its orbit. That flexing produces heat inside Enceladus, helping prevent its hidden ocean from freezing completely. Cassini passed through the plume and sampled material that had escaped from below. It detected salts, organic compounds, silica particles associated with hot water interacting with rock, and molecular hydrogen that may be produced by hydrothermal activity on the ocean floor. None of this proves that life exists on Enceladus, but it suggests that the hidden ocean possesses several ingredients associated with habitable environments: liquid water, chemistry, energy. A small moon orbiting one of the most hostile planets in the solar system may contain an environment where life could potentially survive. That changes the meaning of Saturn's system. It is not simply a beautiful planet surrounded by dead debris. It is a collection of radically different worlds, some frozen, some active, some concealing oceans beneath kilometers of ice. The most frightening possibility may not be that Saturn's moons are lifeless. It may be that one of them is not. Much of what we know about Saturn came from one spacecraft, Cassini. It arrived at Saturn in 2004 after a journey lasting nearly 7 years. For more than 13 years, it studied the planet, its rings, and its moons. It watched storms form. It mapped Titan. It flew through the plume of Enceladus. It traveled between Saturn and its rings during a final sequence of daring orbits. But Cassini carried a problem. It was running out of fuel. Once the spacecraft could no longer control its path, there was a small possibility that it might eventually collide with Titan or Enceladus. Cassini had been built on Earth. Even after years in space, scientists could not completely rule out the possibility that microbes from our planet remained somewhere on the spacecraft. Allowing it to crash into a potentially habitable moon would risk contaminating the very environment we hope to study. So the mission team made a decision. Cassini would be deliberately sent into Saturn. On September 15, 2017, the spacecraft entered the atmosphere. As it descended, Cassini used its thrusters to keep its antenna pointed towards Earth. It continued transmitting measurements while the atmosphere pulled it deeper. The signal traveled across more than 1 billion kilometers of space. Then it stopped. Cassini was torn apart, melted and vaporized inside the planet it had spent 13 years studying. The mission did not end because Saturn defeated the spacecraft unexpectedly. It ended because destroying Cassini was the most responsible way to protect the worlds it had discovered. Humanity sacrificed its explorer so that another world would remain untouched. Saturn seems permanent because human lives are short. But the planet we recognize today is temporary. Its atmosphere changes, its storms appear and vanish, its moons evolve, and its rings are slowly being lost. Scientists do not yet know exactly how long the rings will survive. Estimates vary because the system is complex and the rate of loss may change over time. But the evidence suggests that the rings will not remain forever. Eventually, Saturn may resemble a far less spectacular gas giant. The bright disk surrounding the planet could thin, darken, and disappear. Future intelligent observers might look towards Saturn and never know that its rings once dominated the sky around it. That may be the most important thing Saturn teaches us. Beauty in the universe is not permanent. Planets change, moons break apart, oceans freeze beneath ice, spacecraft fall silent. Even structures that appear eternal may exist only briefly on a cosmic timescale. Saturn is terrifying, not because it is evil, it has no intention. It does not hunt, it does not hate. It simply follows the laws of physics on a scale that makes human ideas of safety feel insignificant. Its storms are not angry. Its gravity is not cruel. Its rings are not a warning. Those are meanings we create because the universe is easier to understand when it behaves like us. But Saturn does not behave like us. It spins in the darkness, surrounded by the remains of ancient events, hiding oceans beneath frozen moons and slowly consuming its own rings. And from Earth, nearly 1.5 billion kilometers away, it still looks peaceful. Perhaps that is what makes Saturn truly frightening. Not that it is a monster, but that something so violent, temporary, and completely indifferent can also be so beautiful.